Welcome to the podcast of Data and Analytics in Business. We will learn from the leading industry experts using data and analytics to solve the problems and create values in practice. We will also learn where the industry is heading to and how data and analytics will shape the industry in the future. Most importantly, how they are preparing their business for digital transformation and disruption in the future. I'm your host, Jason Tan, and thank you for listening. In this episode, we have got Michael Steinmann. Michael is the Director of Technology at Nuance Communications. Nuance Communications is the pioneer and the leader in conversational artificial intelligence innovation. While many of us may not necessarily be familiar with Nuance Communications, the very fact is many of us are actually using its technology in our day-to-day life. Say, for example, if you drive an automobile vehicle, such as, for example, Mercedes or BMW, where you have got that voice recognition speech technology where you can interact with your car and give commands to do things such as play the music, change the radio station, all those sort of things, in fact, are using the technology from Nuance's communication as their enabler. In this episode, Michael went into share with us in terms of some of the history of the development of the speech recognition technology, NLP, from its early days and how it develops to what we are seeing and what it is as today. And that itself included how Nuances help supplying the technology to Apple in building out Siri in the very first iPhone 4. Apart from that, Michael also talked a lot about the cybersecurity and how the world of frauding is changing, where a lot of the security measures that we have had in place may no longer be applied. This is primarily due to that the same very much technology that we have got access to is equally available to the fraudster. In this very particular topic, Michael goes into great detail, share with us some great story of how some of the banks are advancing in their cybersecurity protection using the things like biometrics in the area of the voice biometrics, behavioral biometrics to increase the security protection for their customer. If you are the CEO or the C-level of a large corporate, I think really one of the biggest key takeaway as highlighted by Michael is that the security to prevent the fraud and the security to protect the customer should not be impacting the customer experience that you are hoping to create for your customer. And equally, you want to move forward to the future by applying the newer security measure and protection to protect your customer experience. And many of these newer security technology, not only they are much more advanced, but equally they can run in a very passive mode so that it is not getting into the way for you to serve your customer. As our customers are now spoiled and served and communicated to the way that they want to be communicated, the way they want to be served, customer experience is becoming increasingly important in retaining your customer. With that all being said, you don't want to drive your customer away while trying to protect them. If you have any question for me or Michael, please feel free to send us a voice message if you have it. And as usual, you can find the LinkedIn profile of Michael and you can reach out to him and connect with him. If you like more of this episode and understand how to use the data, technology, and AI to serve your customer, make sure you click the subscribe button to subscribe to this podcast on your podcast platform. Your subscription and your listening is our biggest support to continue in running the Analytics Show podcast. Thank you very much, and I hope you enjoy this episode. Hello, Michael. Welcome to the Analytics Show podcast. I'm super duper excited to have you here today because work for the Nuance Communication is one of the biggest company doing so many sexy things, but no one really knows about what you guys or the company is. So I'm excited to share what you guys do with more people.
Thanks, Jason. Yes, it really is kind of one of those biggest companies everybody uses that nobody knows about kind of stories there. So thank you very much for the invite to be on the podcast. I'm really looking forward to this.
I can assure you that the pleasure is mine. Now, while researching for this episode, I found out that you truly passionate about connecting people with technology, and you are quite an innovator with quite a few patent technologies. If that's okay with you, do you mind to share with us some of your innovation and patents?
Yeah, absolutely. That's the exciting part about working in kind of research and development and innovation in a company is that you get to try out new and different things. And along the way, you pop across an idea that can be patented. And I've got one patent that was issued and accepted and a couple more in the lines. And they're around connecting call centers and what's called CTI or computer telephony integration. So the computer systems with computer systems. And so that way you can use data to more intelligently handle telephone calls. So when a telephone call comes into a call center, if we can use data to personalize that experience, to understand, hey, you called 10 minutes earlier. So more than likely, you're calling about the same thing. Instead of pushing you through all those menus and all that experience that you've just gone through, let's just push you through to the agent you were dealing with and continue on your conversation. So it's about trying to figure out what your needs are and then answer those needs as before the first ring is done. And that's what one of the first patents was about, was connecting digital side to call center agents. So all the information about what you're doing on your mobile phone, what you're doing on your website that's causing you to call one of your service providers, that all of that information goes through so the agent can start to handle you more intelligently than the classic case. And we all hate this, right? Where you call into a call center, the first thing they say is, "Hi, who are you? How can I help you today?" And you go, "Hi, I'm Michael Steinmann." They go, "Oh, just for your security, I'm going to ask you 3 questions. What is your mother's maiden name? What is the first street you lived on? What's your first pet's name?" I mean, it's like you go through that and you go, "Oh my God, I just want to get an answer of when my mortgage payoff date is," right? So that was the first patent. And the other one has to do with biometric security defeating man-in-the-middle attacks. And we can go into that in great detail because that's a passion of mine is on the cybersecurity side. And man-in-the-middle attacks are really atrocious things because sometimes they're very, very hard to defend against. Because when somebody inserts themselves into the tool chain of communications back into the enterprise transactional systems, it's very hard to know that they're actually in there and messing around with communication. So it's very easy when you say, "I want to pay for this coffee," that a man-in-the-middle attack will actually transform that into send all my money to Panama, right? And the bank doesn't know that that's been changed along the way because the bank can't know the intent of the customer. And one of the patents was around using voice biometrics to capture the intent of the customer. That means it can't actually be changed by a man-in-the-middle attack. So it's like a blockchain. It then certifies that the intent, what the customer wants, what their desire is, what the transaction is, actually is what gets transmitted all the way through to the back end.
Fascinating, Michael. That was just so much gold nuggets in there already. I want to go a little bit more deep in some of those later, but I can assure you that I would be very delighted if most of the banks or the call center apply this particular pattern, because I'm one of those persons that I'm just tired of repeating myself 5 or 10 different times exactly the same information.
Oh, absolutely. It's an old story, and I used to love it that on the internet there was in America at least, and I spent 17 years in the States working over there for different companies, but in America there was a website, IHateIBR.com, and it was all about how to get out of IVRs, what buttons to push, what things to say to get you out of the IVRs, because they're terrible and were terrible experiences. So there was a need for people to share information about how to get around these things, right? And I think we can do a lot better in communication. I'm sure we'll touch on that.
And I think it will be becoming better given the current technology. Now, I want to talk a little bit about your current role as the Director of Technology at Nuance Communication. What is your role, key responsibility in this ANZ territory?
Yeah, so I work in the field organisation, and that means I go to all of our big customers, people like Telstra and ANZ Bank, National Australia Bank and Jetstar, and, a lot of companies that you've probably heard of and some that you probably haven't heard of or just know in the background. And my job is to look at what their requirements are, figure out what in our product set and what in the product set around the world from other companies might meet those requirements, and also look at opportunities for creating new products or derivative products of what we have that will meet that customer's need. So looking for opportunity on the research and development side as well. And it's mostly over two different areas. And the first is artificial intelligence in the guise of virtual agents. So we've built quite a few and been very innovative in the Australian marketplace for building those chatbots that are there to help you when those call centres and those difficult experiences we just talked about, when they're too full and you need to get an answer quickly. We've built very, very sophisticated virtual agents that will answer the question. So that involves a lot of things around natural language understanding, which again is one of my passions. And example, I don't know whether you've used them, but if you look at Australian Taxation Office and Alex, that's creation. Jetstar's Jess, that's another one of our creations, or SIBA on the Commonwealth Bank app, which is a really, really good one. We get some phenomenal interactions through there where SIBA can walk you through a whole mortgage application if you want. So you don't have to wait to speak to people. And the other side of my passion and what I do is around security and biometrics, which I've touched upon just before. But that is a really, really interesting area because during COVID, it's gone crazy with the fraudulent attempts and cybersecurity breaches in Australia. We're really a target at the moment for a lot of different cybersecurity breaches. It's incredible.
And I believe that one of the virtual agent is called Alo the Koala for IAG. Is that correct? And what I found fascinating in this particular one is not only it won a Stevie Awards, but also it's fully integrated in the Facebook Messenger. I thought that was fascinating. Would you mind to share a little bit more details about that?
Yeah, so it was quite incredible that the organisation that wanted to put this koala front and centre for their fundraising and their information, they didn't obviously have the staff to sit back and put people answering all the questions on the Facebook page that came up about Arlo. So they reached out to us about whether we could create a VA that would have the persona of the koala. So they wanted a particular persona, that the koala had a particular tone to its expressions, the sentences that it said. So that was playful, but could it answer the questions that the people coming in, because this company didn't want this opportunity for customer contact to get or even just people contacting them to go unanswered. So we integrated our first version product called Nina, which is a Nuance virtual agent technology, our first version of it. And that sat there and quite successfully answers people's questions about, what do you eat? And Arlo would explain to them what she eats and how. And the interactions that you see that people do with these bots are just incredible. So back in the old days, you never wanted to speak to a computer. It was a terrible experience. And you went round and round in circles. It didn't take too much to think about, just booking some travel. And you speak to an IVR and it says, where do you want to travel from? And you go, well, I'd like to travel from Melbourne to Sydney. And it goes, great. You want to travel from Melbourne. Where do you want to travel to? And you say, I told you, Sydney in business class. And it goes, great. You want to travel to Sydney. What class of travel would you like? Business class tomorrow. It never understands you. It just directs your conversation. You have to be exact. Well, when you open it up to the freedom of speech, you get people saying all sorts of really, really interesting things to you. And in Arlo, because it was very much that social bot, we got some great examples of people really interacting with Arlo as if it was a koala. It's like, do you like hanging out in trees all day?
Do you like sleeping 16 hours a day?
Yeah, exactly. But it was great because it helped that company to really connect with the people that they were interacting with and do it in a scalable manner, right? And social media today is the fact that now it's not the 10 people who walk down the street and come into your store. It's the million people in Australia and the potential 10 million people around the world that run over your page, see it, and then try and interact with you. And how do you scale up to that? The only way to really do that is going to be through these virtual agents.
That's amazing. I wanted just to say about what you highlighted about that horrible experience of the IVIs. As someone is speaking with some accent, not only I can relate, I can totally feel the pain of that experience. I think I have to say the experience is much better these days, especially with the iPhone Siri, which I'll come back to that in a second. But I want you to, if that's okay, can you please talk a little bit more about Nuance Communication and share with us about what you guys do? Like we said earlier, it is one of the company where its technology is used by everyone, but no one really knows about it.
Look, I will indeed. So Nuance actually started off as a company called ScanSoft, and we were in the OCR, the optical character recognition business. So what we built was scanners that would read text on a page. So that's a form of interaction if you think about it. And that ended up us creating the number 2 PDF reader in the world. So we know the number 1 PDF reader. And Nuance was the number 2. Again, the most well-kept secret there. And didn't have the security breaches that Adobe did. And it was actually a very, very good product. But the CEO at the time saw that what he was doing was creating a channel of communication into the computer. So written communication, printed communication, and how that then connects to a computer. And it wasn't too much of a leap that he said, it's not about written communication, it's about verbal communication. So when you speak, if we can capture, digitize that, and then make that available to computers for analysis and data capture, then we've got a way of creating some really interesting customer interaction systems. So from there, he went on and purchased a couple of voice companies. One of them was IBM. So I like to say that we purchased IBM back in 2003, but it was only their patents and their voice speech services. So, I have to probably put that out there as well. I can't just say we merged with IBM, and then at some point we bought a company called Nuance, and that was a way better name than ScanSoft, being more around the optical character recognition, Nuance being more around general communications and understanding of those communications, whether it be verbal, behavioural, or even written. So we assumed the name of Nuance during that acquisition. I think over the years since I've been on board, there's been close to 200 acquisitions. So the company grew from a very few sales into about a $2 billion corporation. But the most interesting part is that everybody's used the software and probably doesn't even know about it. So to give you an example, we're actually out on 7 billion devices. And if you think back a few years before the smartphone revolution, and we had feature phones, do you remember those things? The Nokia 6250s, kind of indestructible phones. And the only way to communicate on them was to do that key pressing where you do 1111 till you got A, and then 22 to get B, and you would go through and spell that way. And it was very, very difficult. And then someone came up with a method where it would predict the word based upon just a single couple of key presses. And that was known as XT9. That was Nuance. So everybody who used that predictive text entry system was actually using Nuance software.
Fascinating.
Right?
Yes, I remember those days.
Yeah. And then you go on to the minute you start yelling at your car, yelling at your phone and saying, dial mum, or give me directions to, if you hop into your Ford or your Mercedes or your BMW and say, give me directions to the local coffee shop, that's all Nuance as well. So we do all the speech recognition in a lot of cars, a lot of mobile phones, a lot of devices. What I used to love to say during the beginning of the smartphone era was there was a coffee company, a company that produced coffee machines, actually, in Italy, which is a good place to be if you're going to produce coffee machines. And it was voice activated. So you could yell from across the room, hey, brew me a cup of coffee, and it would do that. That was Nuance. So all of these different kind of devices down from the retail side up to the enterprise side is actually Nuance software. So people interact with it on a daily basis and don't even know.
Fascinating. I must say, even I have done all of those research. I actually don't really know. Now, I actually want to highlight one thing about this. Probably lots of people don't even know, including myself, who is one of the iPhone user. And I have been with them for a long time. So many of us, right? Myself, we are familiar with this speech recognition or the advanced natural language processing. And I think Siri has a lot of credit because they are sort of like the very first one introduce it to the mass public, devices that we all hold on our hand. But what many do not know is that Nuance actually helped and supply the technology to Apple, to Steve Jobs in creating Siri. Now, without going into the greater details, would you please enlighten us about this development?
Oh, absolutely. That's an interesting one. I mean, if you think about it, right, prior to smartphones, there was a lot of speech interfaces, but they were what we call voice command interfaces. So you could say, brew coffee, but you couldn't say something like, brew me a coffee and tell me what the weather is like today. In other words, a conversation. So it was all command-based. And it was really a company. It wasn't Apple. If you go back to the very, very beginning, Siri was several app developers that got together. I think some of them might have been UI designers from Apple itself that had left Apple and started up a company. And they were building a virtual assistant that you could pull off the App Store and use on your iPhone, which was Siri. And that was all using Nuance speech recognition and text-to-speech technology. So when we think about a lot about what we call ASR or speech rec, it's about understanding what you say. But when the machine replies back to you, you have to have an interface that's able to take the words that you want to present back to the customer and synthesize them into speech. And for the longest time, a lot of companies would use pre-recorded speech, so somebody actually speaking, and they would then cut and paste them together. And we've all seen those or heard those interfaces where they say, your balance is $300. It's like, it doesn't sound natural. It sounds really bad to the ear because it's real speech cut up, put together, and it doesn't have that intonation and flow. So we have a text-to-speech system. So this synthesizes text and produces a natural sounding speech, and that was used in Siri as well. So when Apple saw the future of devices, being able to speak to them, being able to talk to all of your different components, I don't want to get up and turn the lights on. I just want to yell at my light switch, hey, turn the lights on, make them a warmer light and dim them down, please, right? Or set me up for TV night. That would be a much better interface than, okay, let me open up an app, go into home, select the lights out of smart home, set the ambient light. That's too much effort. So being able to ask for it. And when Apple thought about that and they said, okay, we're going to do this, they went out and bought Siri, the app developers and the application. And so that then was incorporated into the platform. And one of the things Nuance at that point in time had been doing speech recognition systems for close to 15 years. And Siri and then Google followed and Samsung and Microsoft. And then by putting it in the platform where we interact every day, they're not very, very sophisticated when you think about it, as in understanding what I can do. But I know I tend to use it quite a lot, set my alarm, tell me what my day is like today, what's the weather like. I don't want to have to open up the phone and navigate into the different apps. I just want information. So I use Siri as that kind of launching point to set up my day, to find out what's going on. And it's a much easier interface than doing swipe and tap all the time. That's basically one of the great things that putting them onto these smart platforms has done, is that it's made it all acceptable for us to talk to the phones again. Because we went through a bit of a time where all of a sudden you didn't want to talk to anyone. You wanted to chat with them, use your two thumbs and type. So we didn't want to talk to our phones, right? It's kind of weird, really. But if you think about it, we didn't want somebody to call up and you send them a text. No, I don't want to talk to you right now, but I'll text you. So it all of a sudden made it okay again to speak to your phone. So you see all these people walking down the road going, Siri, play the latest hits that I have, or play my playlist, or okay, Google, play the latest TV show on my TV. The smart connected house and this natural language interface has become ubiquitous, and that's a really good thing. Now it's just got to come intelligent.
And I think this is probably this whole idea of using that as a landing pad, this smartphone and crowd processing. I think it really were the catalyst of how this technology for the mass audiences, which subsequently resulted in all this variety of this speech technology service we see today. It is really this tool thing that making this happen. Do you think that is the case?
Well, it's kind of interesting that you bring that up, because, look, it's really about data. I keep talking about a customer interface and being able to communicate. But at Nuance, we did a bit of a study around VAs, and we found out that you get 2 chances with a customer to understand what they're saying. So when they say something to you, whether it's speech, whether it's typed, it doesn't matter. But when they say something to you, you've got 1 chance to say, I'm sorry, I didn't quite understand you. What, did you mean this, or this, or could you rephrase it? And when they say it the second time, if you don't get them at that point in time, then you've lost them in that channel. So they will then abandon that conversation and go someplace else, which is normally a higher cost channel, or potentially abandon that product, that enterprise, that interaction altogether, which is a really bad thing. So how do you get it right? It's around the data you have. And that is what really creates a differentiator in understanding language. And at Nuance, we've got a corpus of data that extends back to one of the companies that we purchased, Philips Interactive, which was Philips, the very, very big company, used to do speech recognition, and we bought those assets off them. And along with them came some really early corpus of data, but we've got data going back 20 years. Billions and billions of speech. So when we use that speech, when we use the way that people talk and that language, we can build statistical models. And just recently, in the last couple of years, we've moved from statistical models to deep neural networks in understanding the parts of a conversation, or understanding how phonemes, the individual portions of a word that you say, is called a phoneme. And there are 46 phonemes in the English language. And the way that you put those together is what forms words. And this is how we understand then what you say. But it's all about the data that we have, being able to create those models. And if you don't have those, you don't get understanding. And if you don't get understanding, we can't actually answer the customer's question. So it's all about the data you have.
Speaking of this data, and I think what it got me thinking a lot of time is that the opportunity and also the creation of the specialization in different industry. So what I mean by that is currently you have all of these big platforms like your Google, Microsoft, Nuances included. Now, each of these provide a generic AI speech recognition technology, but they may necessarily have that domain expertise or the data being trained up in any specific industry. So in that case, it seems like there is opportunity for the startup perhaps, or maybe some of the bigger company in certain section, they build up their domain expertise. So suddenly that you have these AI speech recognition that really, really understand the insurance in certain regulation, jurisdiction, then at the same time, you have another different company that again utilize this bigger platform or the technology provided by Nuances, but then they have that domain expertise in the retail market in certain area. Do you think that is how would be play out in the next 15, 20 years?
Absolutely it is. And that brings across a couple of really interesting concepts, right? And it's all around natural language understanding. And the first one is, you and I are speaking here, we're understanding each other. We're not expending a lot of compute or brain power to do that. It's just natural. We've grown up with it. But when you think about what we're doing, it's a complete and utter miracle that we're able to communicate, right? Understanding those words. Because when you look at it from a computer's perspective, it is so difficult for a computer to understand what you and I are doing right now. Phenomenally difficult. And it's based upon linguistics and a couple of things that we use in language that make it extremely difficult for a computer to understand. I'll bring up some of those concepts now. I'll use a couple of linguistic terms, but I'll explain what they mean. And the first one is anaphora. And anaphora is parts of speech that you and I have a context of, so we don't keep repeating the context over and over again. We'll use one of these anaphoras. And anaphora is the he, she, it, they, thems of the world. So I don't say, hey, Jason, how are you doing, Jason? Jason, are you doing fine? Are you doing an interview now, Jason? I don't keep using your name. I'll say, Jason called me up and then we started an interview. Then we. Who's the we? If you think about a computer trying to understand that, when you say, actually, cancel my transaction, I'd rather fly to Melbourne. Well, what's the context of that? My transaction is inherent in context of something that I've done before. And the computers got to understand these its and these days and these she's and put it all together into something that's meaningful for what we're trying to do. So when you look at something like Apple and Google, they're very, very good at the generic NLU models. They have lots of corpus of data around what's the weather like and can you play this song. But what they're not very good at is, I'd like to move $100 from my checking to savings and open up a new savings account, right? So the more enterprise kind of business side of it, there's not a lot of that corpus of data that they have. And at Nuance, we do. All of our VAs tend to be on the enterprise side. So we understand how customers communicate with companies. What type of spending did I do last week? Can you find a transaction that was done at a coffee shop last week that's around $5? That kind of deep linguistic capabilities of understanding particular enterprise questions. That's what we have. Now, the opportunity comes in, just like you said, around insurance or around transport or around telecommunications that has a deeper domain knowledge in a particular area. I think there are people rushing to do that, to build up these models, because it can be quite time-consuming to build up the models, get enough data to produce a VA that's going to be able to understand your customers saying your product names and talking in your world. And you think about something like telecommunications, right? It's a very, very particular language when you're saying, I'd like to update my plan, have more minutes, and what's the latest speed that NBN Co can give me. That's very, very hard to discern without the context that I'm speaking to a telco and I'm talking about my service, and there's a lot of buzzwords in there that we tend to use. So that specific domain expertise, I think there's great opportunity for people to build models and then be able to use those models in different circumstances. It's all about the accuracy.
That opportunity is interesting to think about. As I was thinking about what you were saying, is then how do you structure the business model and the commercializing that opportunity? If we were using the telecom as an example, the number of players or the service provider of the telecom in Australia or in any given country, it would always be limited, i.e. 5 to 10 or 3. So how do you structure, how would that be commercial feasible to build up that whole entire specialization just to sell in that? Is something that maybe someone they have to think about that.
Well, you're picking up some really, really interesting points because the world's, it's got the perfect storm colliding. We've got big data, and I think none of this is possible without big data. Our models are not possible. Our understanding's not possible. And the transactions we're trying to do and figure out for our customers are not possible without that big data. And especially around personalization. I talked earlier about how it would be great to just call in and have the system go, before I even say a thing, right? Have a system go, "Hi, Michael, I see that you're calling in again and your bill hasn't been paid. Do you want to pay that off with a credit card on file?" And all I have to do is say yes, and I'm done. I would love that, right? But that requires big data. But what we come through and how to build this out is the other kind of part of the perfect storm is microservices. So now, instead of having to build a lot of this capability ourselves, we can just go out and use someone else's capability. And Nuance introduced a tool about a year ago called Mix. So this is a VA, a virtual assistant, AI, NLU, speech recognition, text-to-speech synthesis. That's all microservices on the internet. So you don't have to go build that. You can build the intelligent part, which is that model that understands the domain of telco. And then how that gets presented in the VA that gets built around it and the NLU that uses your model is all services that you can start to build for free online. And a lot of these microservices are like that. So you can build the product. And when you deploy and sell to customers, that's when costs come into it. But it's about being able to innovate. And, we talked a bit about my career on the innovation side and being able to use lots of different services that I can bring into the customer experience. And my differentiator then is that model that I built. Yeah, and then I can sell that service. And whether that service is a SaaS model, software as a service, or whether I then sell the data itself is an interesting question.
I think that is really the direction that Nuance is going. And if that's okay with you, I want to use this different analogy and present it to the listener in a way that is probably people are familiar. So, for example, when we go to a website, 20 or 30 years ago, Amazon would have to build every single thing by themselves, i.e. your recommendation engine, your chatbot, sending the email, or monitoring. But these days, building a website that can rival, not necessarily Amazon, but as good as what Amazon would have 15 years ago, is just like the microservice that you were describing. No longer anyone would have to build the email thing. No longer people have to build from scratch about monitoring and how people are using their website. No longer they actually even have to build a chatbot. No longer they have to build the help desk because each of those has already been created and is considered as a microservice. All they have to do is just calling the API to use that. And that is how a modern website is built these days. In translating that analogy back into this AI, the speech recognition, it is truly indeed the way to go. And someone just have to figure out how to pack different of these microservices to create a solution that solves the problem for the domain.
Yeah. Look, you've picked up on it, right? And that's the important part. If I'm coming through and I go, okay, I've got telco experience. I know how to build the conversation between a customer and a telco to buy services, buy a phone, and configure those services. I know what that conversation looks like. I know how I can make a really good interface. But with that expertise, I might not be a natural linguistic, a psycholinguistic expert. I won't be a speech recognition expert. I won't be a text synthesis or speech synthesis expert. I won't be a big data expert. I'll just go out and use all those services, the best ones that are out there, and I'll bring my domain knowledge that builds that model. So it makes people much, much easier to get an idea up off the ground. I'll give you an example about that. When I said we built Arlo and Alex at ATO and Jess, it was built a lot by their experts in the domain and a lot by our speech scientists and our VA experts. And it was a collaboration between the two. One of the things that we're doing with Mix is putting all that speech science, all of that specialized knowledge into the platform. So all you really need to do to interact with it and build these kind of VA bots is to use your domain knowledge. And I had a particular customer in New Zealand that wanted to build out a particular customer interface. So they got onto our tools and they hired a TV producer. So a guy who did a TV reality show about police over in New Zealand, they hired him to come in and build this interface. I spent an hour working with him to show him how the tools work. And he built a whole VA bot. Now, this guy is not even a technical guy, right? He's got deep domain knowledge about human communication. That's what his expertise was, how to present things, how to put ideas over. That's what TV producers do. And he built a phenomenal chatbot that was able to get some really interesting transaction and concepts across. We were really impressed with that because he wasn't a technologist. And that means that innovation is going to come not just from us tech weenies sitting in front of a keyboard programming in. I'm doing a lot of Swift programming nowadays, and we all do a lot of Python programming too. It's not those people who are creating a lot of the innovation. It's these people who are non-technical, but the tool sets allow them to plug and play to create just phenomenal products, especially on the customer interface side.
And I think that is really where the innovation and what all these platform and the underlying platform that you guys are building, allowing all this future to happen. So that is absolutely amazing. Now let's go deeper into this topic with another of your areas of expertise, cybersecurity or security. I read in one of your articles online where you were talking about replacing the traditional use of pins and password with voice biometrics. Tell us more about this.
So, passwords. Oh, the bane of my life, the bane of everyone's life. I don't know, Jason, you probably have a password manager that you use.
I do.
Yeah. Why? Because there are, on average, there are 68 passwords we need to manage. I have more. You probably have more. But on average, most people have 68 passwords they have to manage. Now, if you want to have a password, it should be greater than 16 characters, include upper and lower case, a special character, not be identifiable, not be words. How are you going to remember 68 of those? You can't, right? So what we all do is we reuse one or two passwords, and will make them simple, and that's where the problem with passwords come in, is that there's a file on the darknet that includes 8 billion email addresses and passwords. So every breach that every company has ever had, and we talked about Adobe earlier on in this interview, Adobe lost 150 million passwords and clear text passwords and email addresses. And I was part of that breach. So whenever you signed up for Adobe Acrobat, you'd have to give your email address and put your password in there. And I found out that my email address and password is out on the darknet because of that Adobe breach. And there's been a couple of really, really famous ones, all the way through Addison Wesley to just very, very large companies losing these passwords. So the bad thing is, more than likely, your email address and passwords are out in the darknet. They can be used to be breaking into different systems. But it's also given us a chance to do analysis on that to see how good password management is done today. So you know what the number one password is?
Hello, 1, 2, 3.
Close. 1, 2, 3, 4. Right? That's the number one password. The number two password? Password. Right? It's terrible. And with the top 5 passwords in this list, you can break into 20% of the accounts. That's no security. That's no security whatsoever. So this is why passwords do not work. There's got to be a better way. I don't remember them. I use a password manager. A lot of people do. And even then, LastPass, which is a very famous password manager, that had a data breach and they lost their email addresses and passwords. So the minute you start using this technology, it's not as secure as you would like it to be. Now that all of my money, all of my transactions, all of my dealings with all of my service providers, whatever I buy is now online. That means that my whole financial future and all of the details around my finances is online too. I need it better protected. So how do we do that? And that's where Nuance, working in speech recognition for so long, discovered that we are all unique in the way that we speak. And that uniqueness is basically like a fingerprint, and we can use that for security. So you can use the individual components of your voice, your accent, the way that you say particular words, your pauses, all of that identifies who you are. And when we use that in conjunction with, say, you're talking to that example we used earlier where you're speaking to a customer service agent and you're going to book some travel. So when you call in, they currently ask you those terrible, terrible questions called knowledge-based authentication. What was the first street you lived on? What was your birth date? What's your date of address? What's your address? What's your date of birth? All of those knowledge-based questions are meant to securely identify you. They're real pain to give, but they're meant to secure you from fraudulent use. Well, the problem is with social networks today, a lot of that information is online. So finding out someone's birthday, finding out their address, it's easy, it's trivial to do, and then do what we call account takeovers. Instead of going through all those questions, the experience that we give with voice biometrics, instead of, hi, welcome to ABC Travel Company, I'm going to ask you security questions now. What's the first street you lived on? What's your address? What's your date of birth? And you're going through what seems to be the fourth degree, all these questions, just to get through to what you want. Instead of that, we use voice biometrics and we say, hi, Jason, what would you like to do today? And as you're saying, well, I want to travel from Sydney or Brisbane to Melbourne and then go on to Perth. In that amount of time where you say, I want to travel from Brisbane to Sydney, we've done your voice biometric, checked out it's you, given you the big tick. You don't have to give passwords. You don't have to give PINs. You don't have to answer knowledge-based questions. And it's very, very accurate, very accurate.
So the big question I have about these that I'm curious to find out is that the fingerprint, doesn't change unless they use it in certain way in the trade. The eyeball doesn't change, but our voices, maybe it doesn't change in the way that it completely physically change, but I suppose our tone would change in the morning versus the night. Our tone would change as we get irritated versus the calm mode. Our voice would change in a certain way, and perhaps for example, maybe my accent change. How does the technology take into the account of those changes?
Oh, now we're getting into the good stuff. Yeah. So I call it the first coffee issue, right? Your voice in the morning before you've had your first coffee is very different because first coffee wakes up your vocal cords, warms them up after you've been sleeping all night. So you'll sound very, very different. But the interesting thing is it's this variances in the way that you speak that makes the whole voice biometric secure. So let me throw you a couple of examples. You said the fingerprint doesn't change, and truly that is correct. It does not. And that kills one of the first rules of security, which has to do with when a credential is compromised, how do we stop that credential? So when your fingerprint is compromised, how do we get rid of your fingerprint? We can't, right? Because it is always the same. It is always there. So what do I mean by compromising fingerprints? The interesting thing was when Samsung first came out with their fingerprint on their phone, it was defeated, I think, within a couple of minutes by a couple of people at the event where they introduced the phone. And what they did was a guy got a bit of sticky tape, lifted the fingerprint off the phone, transferred that onto a bit of gel, and then put the fingerprint back on and was able to break into the phone. Right? It was that quick and that easy. So how do you then say, okay, I don't want that fingerprint to be used anymore when we can't change that on the person itself? Well, with voice biometrics, because we're actually looking for variances in speech, it can't have exactly the same speech that you had 2 minutes ago. So if it does, if you sound exactly the same and you have all the same, dare I say it, nuances in your speech, all the same phonemes, that means it's a recorded attack, because you can only sound exactly the same once because it's a recording. So we can pick up that someone's doing a recorded attack. So how do we then change your voice biometrics to get rid of that recorded attack? Well, we change what you say. So if we're using a passphrase like at ABC Travel, my voice is my password, I just get you to say something different. And now we've got something completely different that recorded attack can't break. So it is one of the only biometrics, because it is constantly changing, actually makes it secure.
Right. That is really interesting way to look at it. Something that I would have to think about. And presumably it also, like you highlighted in various parts throughout this conversation, is that a lot of time all this security and the voice recognition, it really comes down to the underlying data that you have been collecting and building up the model as well. So that is really the cornerstone and the foundation of all this.
Absolutely. Now, the data is where it really gets interesting, right? Because we have the data of your voice and we know all the different phonemes, we can then go to open speech patterns. So instead of a common passphrase like, my voice is my password, and we've all heard, do you remember that movie Sneakers, where the recorded attack, they recorded a guy over a day and then they spliced all the words together and he said, my voice is my password, and they were able to break in? Well, gone are those days, because we're actually looking at the way that you do natural speech and the phonemes, and it's the way that you say those individual sounds that come together. So data about understanding how all those phonemes are kind of unique to each individual, that produces the models that we're able to then use in security. I like to give another great example of exactly how big data really works with biometrics, because we're one of the only companies in the world that use voice biometrics to convict a fraudster based upon his voice. And it's kind of interesting, because the way that you find fraudsters is by using data, and huge amounts of data. And this was a bank in England. And a bank in England noticed they didn't have voice biometrics on the telephone system, but they looked through all the quality assurance recordings and found out there was a fraudster in there. So we identified a fraudster who had done an account takeover of a single account. And he pretended to be this person, gave out the bits of information that we're talking about earlier, the knowledge-based questions, answered them all correctly, and then stole money out of that user's account. So what we were able to do was go through all of the bank's transactions over the last week and find that voice whenever it popped up. Right? And the interesting thing was, now remember, these are all, according to the bank's authentication system, they were all legal transactions because a person answered all the questions correctly. But we noticed it was the same person over 20,000 accounts. And it was a huge amount of accounts that he had called in, socially engineered himself into, and he stole over £4 million, which is about $8 million Australian, over a several-month period. But the wonderful thing was, by looking through all that data, we actually found a single account where it was actually his name and address. What he had done was signed up for an account to test the security systems of the bank, gave his actual name and address. So we're able to notice that this guy, this name and address, that's his name, sent the police after him. They knocked down his door, and as the story is told to me, as they knocked down his door, he was on the phone with the bank taking over another account when the police came and grabbed him. And they put him in jail. But $4 million or $8 million, £4 million, this single guy was able to take over. So it's by being able to use all of those transactions that have been done, all the audio, that we can see patterns in the audio, not only the same person on multiple different accounts, and that's definitely a flag, right? But the way that those transactions, when they're done, the time of day, and that gets us into behavioural biometrics, the time of day, the type of transaction, the speech that he uses. So that's the other thing that we came across when we were looking at the whole thing around voice biometrics. We started to see a pattern in the way that we use not only how our voice sounds, but the words that we use. And the words that we use are another unique identifier to each of us. So we each have our own corpus of words that we tend to use when we communicate. And that is a pattern in itself in the data that we can use to identify certain people. Well, when we put that system up against the bank's data, all of a sudden we found out there were all these different accounts, all these different people, but they were all using exactly the same language, exactly the same. And that's when we discovered an attack vector that's based upon these fraudsters. And work with me through here because I'm going to take you through a very, very interesting case. These fraudsters, when they found out that their voice is being recorded, can be found, so they're not going to use their own voice over and over in each account because that's an easy way to pick them up. And certainly a lot of a 45-year-old male fraudster can't usually pass himself off as a 18-year-old female. So taking over those accounts are rather difficult. Well, in Eastern Europe, there are companies that you can hire and you can say, here's a script. I want you to read that out, call this bank, and I want this one to be a female. I want this one to be a male. I want this one to be a 70-year-old female and this one to be a 50-year-old male. And they have a big call center. And these people will then call the bank and then read out that script. Hi, I'm Michael Steinmann. Here's my information. I'd like to move all my money to Panama. They're all using different voices, so it's harder to catch. They're using voices that are sociologically very, very similar to the person whose account they're taking over. So it's harder for an agent to hear a mismatch in, say, the gender or the age of the person. But the big thing is they all need that script. And we picked up just on the variances of the words that they used, and they don't have to say exactly the same thing. It's the intent, the ideas, and the way that the ideas come through in the words that they use. That's how we're able to identify them. So we can identify when these script attacks and takeover attacks come through. And that's because of big data as well. So that's been a really, really interesting one that we've been able to do. That was kind of one of those eureka moments. We didn't build the product to find script attack. We built it to just understand the customer's ways in speech and then authenticate and credential the customer. But it showed us that we can pick up fraud because the speech patterns for fraudster scripts are going to be very, very similar.
There is just so much to unpack in these particular use cases in the banking sector, like the voice biometric, fraud, big data, etc. Really, really love it.
It is. Oh, look, it's an area I could speak on for hours. I mean, I really, really love this kind of stuff, right?
I can imagine. And I suppose any other industry that has got a big, large call center could potentially benefit from this, apart from the banking. What other industry do you think that would reap the most benefit out of this voice and behavioral biometrics technology?
Well, that becomes a really interesting one because now it's not about a call center, right? It's about whenever you touch on communications. So wherever people are communicating, and mostly from my point of view, I've got the rose-coloured glasses of the enterprise because I work in the enterprise area, not in the person-to-person area, but in the B2C, the business-to-consumer. And that's where it fits extremely well from my point of view because you've got lots and lots of consumers speaking to a single organisation, so you can secure the communications. But it's not about call centre communications because, as you said earlier, social media has just changed the world. Now customers want to communicate to their service providers, the people that they buy goods and services off, wherever they happen to be. So if you're on Facebook, you go to a Facebook page, which is a restaurant, you want to communicate to that restaurant through Facebook. You don't want to have to call them. You're already on Facebook. You've got a Facebook page. Why would I want to call you, right? Why can't I interact with you now and book a table and do all of those things that I want to do? And the same is if I happen to be in WhatsApp. Or if I happen to get, this is the biggest pain I personally feel myself is, do you ever get those SMSs saying, your flight is delayed. Please do not reply back to this SMS.
Yes.
What? You reached out to me. You communicated to me. I want to answer back. Book me on the next flight. But now I'm going to go to my website and or into my email. Or why is that? Why can't I just reply back to that SMS and say, great, book me on that flight, the next flight? We want to interact with the channel that we happen to be on. And that is a very important way of getting this underlying data down and then taking away all the issues around the communication channels to kind of equalize them. So no matter where I happen to be, I can get the answers that I need. So the interesting part around that is then making sure that I've got that securely. And there's a real big problem with SMS, as you probably know. SMS is not a very secure mechanism. So whenever I see banks or telcos or anybody sending me out a second factor authentication, where they send the little number over an SMS, those are really terrible things because that's no security at all. Do you know about those?
Yeah, I do. I think for me, from the convenience perspective, I think it's convenient as opposed to in certain bank or certain jurisdiction, they likely use the passcode generator with a separate devices, separate token. I'm not really a big fan of that. I think it just makes life difficult, but I can see where you're coming from in terms of that security challenges. Yeah.
Oh, look, two-factor authentication over SMS is really terrible. And the reason why it's terrible is there's a attack vector called a SIM swap. This happened. Well, actually, it happens quite a lot, but it happened the first time I saw it was about 5 years ago when it first started coming up really big to a guy in Sydney. And the attack goes kind of like this. What had happened is the fraudsters targeted this person. And in Australia, we have number portability, and it was one of the best things ever. It was actually groundbreaking and unique around the world that the Australian government put down rules that stopped Telecom Australia from being, as it was the main telco provider back during deregulation, stop them from owning the world and stopping all competition by saying you can't port your number to another vendor. So the government said, no, anybody wants to port, you have to port right away, and you can't put barriers in their place. So to port a number, all it takes is your name, date of birth, and address. That's it. So you call up Telstra, and this is what happened to this guy in Sydney. The fraudster called up Telstra and said, I want to port my number to Optus. Here's my 3 bits of information, my name, date of birth, and address. And Telstra said, good, that'll be done, in the next 5 to 10 minutes, 20 minutes. And certainly it did. So it ported across to Optus. And once they got that, they called up the bank and said, hi, Mr. Bank, I'd like to make a withdrawal of $45,000 from my account. And the bank said, good, I'm going to send you an SMS to two-factor authentication. Well, guess where that went? To the fraudster's phone. Now, the whole time, the actual victim didn't know his phone was even not working because he's obviously not getting any phone calls, but the phone doesn't do anything more than just kind of sit there. So the fraudster got the 2FA, read it back to the agent. The agent goes, well, you got the device, so therefore you must be the right person, and moved all the money. So that's how easy it is to do the SIM swap. But it gets even worse. There's a place on the internet where the majority of the world's coders share code. It's called github.com. And we all share snippets of code out there. It's one of our main areas where we communicate. It's a great place to be able to get ideas, get libraries, get information, not have to recreate the wheel. It's kind of the microservices of programming. So as a programmer, you live on there, you share your code. It's fantastic. On there is a library, which is malware that you can compile and put on a Android phone. And what this does is will sit in the background. So it's a piece of malware. It sits in the background and monitors all your communication. So if it sees any of these 2FA numbers come across, it will then send it to a central server. So it can hide them, it can read them, it can read all your messages. And it's very easy, and that's a classic man-in-the-middle attack. It's very easy that when you say, okay, I'm going to do a transaction, I'm a fraudster, I'll do a transaction against this person. I don't even need to be near their phone. I don't need to even do a SIM swap. You call up the bank sends their code, this piece of malware picks it up, sends it straight to you, and you can read that number back. So things like two-factor authentication are really no security at all. You've got to secure it in other ways. And we've talked about voice biometrics being one of them. But another one that's up and coming, this is really new cutting-edge technology. It's called behavioural biometrics. And in our security suite at Nuance, not only do we have voice biometrics, but we also have fingerprint and facial. It's horses for courses kind of thing. But we introduced a couple of years ago behavioural biometrics. And what that does is look at everything else that's going on that phone and put it all together as a big picture of whether that is a proper transaction that's coming through. So what I mean by that, and again, think big data, is the transaction something that this person does? Today, right now I'm buying a coffee from 7-Eleven, and then 10 minutes later, I'm buying a car in New York. Well, that travel between Melbourne to New York in 10 minutes could never happen. So if we use that as a data point, we can say that one of those two transactions actually was fraudulent. And since I always buy a coffee from 7-Eleven, more than likely that's an okay transaction. Since I never buy a car in New York, that's the transaction that seems to be fraudulent. So we can stop that transaction on the authentication part before it even goes through. So by using behavioral information around the platform, what we're using, the transactions, where they occur, we can stop fraud before it even happens. So it's good for the credit card companies. They don't have to pay out. It's good for consumers because when you lose money, say it's not a credit card transaction, but someone's doing a direct transfer, especially with the new payments gateway, we can stop that before it even goes through, because once the new payments gateway payment's done, it's gone. So it's very, very interesting on the behavioral side to get all these different indicators, because it's one of the biggest issues. I'm going through so much now because I'm really excited about this this product.
I suppose I want to highlight one thing, though, is that because of the advance of the technology and all this cloud technology, not only is available to all these enterprise and the good people, is equally available. All this technology are available to all the fraudster as well. So that being said, the security measure, the cybersecurity measure to protect the account, to protect the customer, etc., is going to get much harder in the way that how we have been operating, i.e. that two-factor authentication, asking the security question, what is your mother's maiden name? All those sort of stuff should be reconsidered and moving forward to protect with more of these biometric stuff. And I'm just going to quickly highlight one of these biometrics from what I read in terms of the research about what you guys do, but also many other companies may do, is that biometric not only is translated into our voice, but even to the way that how we are typing in our devices, how we are communicating. So that is perhaps the biggest takeaway that the listener should be really taking with this about making more advanced cybersecurity with these more advanced biometrics.
Look, if I take the one point and I say it's probably the most important point that I'll talk about, is exactly what you were talking about right there. And that is, we keep putting barriers in the way of customers, and it's not a great thing. It's not a good thing at all for business and not a good thing for communication. So I'll give you an example. Have you ever done those captures, the Google captures, where it says, please identify all the chimneys? Oh, gosh, okay, well, this one. Okay, now identify all the crosswalks. All right, this one. I just want to do my transaction, right? But it's getting me to free labor to go do image identification for Google under security, trying to find out if it's a bot attack. When we put these barriers in the way of customers, it is not a good customer experience. It is a terrible customer experience, and customers hate those things. We all hate them. It's like every time I see the capture pop up, I'm like, oh, no, not again. I don't want to go through that. By using behavioral biometrics, as you said, it's the way you type at the keyboard. It's the device you use. If I'm always on my iPhone and all of a sudden something comes across as Samsung 20, That doesn't necessarily mean it's not me, but it does mean let's do a bit more security here. Let's look a bit more deeper at this transaction. Let's look at what's happening here, because this is out of the ordinary for Michael. So this is the thing we know computers are great at, understanding patterns, understanding what I normally do on a day-to-day basis and what's abnormal behavior. And when we can identify that abnormal behavior and stop it before it ends up being a breach, being a taken over identity, being money taken out of my account, all the better for our customers. So being able to say, yep, you're on Chrome, on a Mac OS, in Melbourne, you're typing, it looks exactly like the way you normally type, everything else fits. So you know what? I'm not going to put that captcha there. I'm not going to put that password there. I'm not going to do 2FA because I've got all these other indicators that say it's you. Now, the interesting thing about those indicators, I don't have to physically do anything for the credential. I just have to do what I normally do. No barriers are put in my place. I don't have to stop, answer a security question. I don't have to stop, put in a password. I don't have to stop, do a captcha. I just get to do what I want to do so I can continue on with my life. And that's where I think the world really needs to start to understand that all of our security systems have to go passive. And by passive, in the background, checking everything that I do, making sure that this is consistent with me. So I've got a system that's, like a security system in a house. It's passive. It sits there. It's always going. It's always checking my windows, the movement of people in and out of someone's breaking down the front door. It's checking those things. I don't have to go out there and say, oh, right now I think I might be under attack, so do a security check. Right? I want something that's always working in the background and is protecting me all the time, all the way through the transaction, but not getting in my way to do that transaction. And that's a really big change that we're starting to see companies understand that, because you just can't keep putting these barriers in front of customers and expect to get good NPS scores and good customer experience scores.
Fascinating. I think I'm seeing some of those already. I don't quite recall the website or the services, but I do feel that there are certain way that sometimes just the way that they voice that security message, we recognize some unfamiliar pattern, and we would like to ask a few more questions. So it really, the trend is about becoming that how these technology are protecting us in the background without us even knowing that. How fascinating.
I've got this prototype that I built, which is truly phenomenal. I can hold the phone in my hand, that's all, open up an app, and it'll show me my account balance. I then hand it to someone else. They open up the app, and it puts a password challenge and a authentication challenge in their way. All right. So just the way I hold the phone is enough for it to open up and show me my transaction and allow me to continue on to work. So even gets around all those issues around facial recognition. We know that the cameras are now always on, checking our faces. And even the Apple facial recognition was defeated by someone using photos off of Facebook. Did you hear about that?
No, I did not.
Yeah. So a guy got photos off Facebook, used a very cheap 3D printer to print out a mask, put that up in front of the phone, because Apple facial uses infrared dots, I think like 10,000 of them, to map out the three-dimensional features of your face. So that mapped out the mask and opened up the phone for him. So he didn't even need the person to sit there for a 3D scan. He was able to do that all very, very cheaply right off of Facebook photos. So very scary. By using behavioral biometrics, it's in real time and it's all the way through continuously. So you don't have that one credential that opens up the world. It's always checked passively in the background as you're moving from screen to screen, as you're doing a transaction, as you're going about your daily business. It's always checking. And I think that the big difference, and that will change the way we interact with the world, because now it's more about convenience then. Security is a given, and that's got to be a case. Security first, security always running, security always going, but just let me get down and actively do my transaction while you're passively doing security.
Love it. And I suppose my last question for you is more for the working professional. is that then all of these technology appear to introduce more new roles. So one example would be like voice user interface designer, or the people who design to understand all of the subtlety of the biometrics. My question then is, given that you're at the forefront of these, what type of skill set do they need, and how can they break into this industry and these new roles that are not even known to most people?
Boy, that's really another very, very interesting topic, because when you think about it, right, in the old days, if you were going to get into high tech, you went and did a computer science degree. You learned how to program, and you came through and you've got all these programmers building user interfaces, and what they produce is Microsoft Clippy. If you remember old Clippy, it was a terrible experience, right? That's what happens when you put programmers in charge. In this day and age, technology is just at such a rapid, accelerating pace, especially around AI, deep neural networks, being able to figure out patterns, that the importance has really shifted not from the technology, but to the customer experience. And given that, I'm seeing more and more people coming out with the soft degrees, art, linguistics, people who are TV producers like that New Zealand guy that I told you about earlier. They're the ones who are really coming through and designing that front-end experience, because as technologists, we're really good at, once we're given a really good design, of producing the technology to enable that. But we're not very good at creating that initial customer interaction. And those type of people are going to come from arts, going to come from languages, they're going to come from journalist majors, people who do communication for a living, such as yourself, but you straddle both the worlds of tech and communications. But those people who kind of straddle those have both experiences in the communication, in the soft arts, as well as the sciences. They're going to be the true innovators coming through, because it's all about thinking outside of the API calls.
I think that's a great news for a lot of those people who never see that they are good at programming or don't want to become a programmer, but they can thrive in the innovation.
Well, it means those people who are doing a Bachelor of Medieval History actually going to have a place to do some interesting, really innovative work in the high-tech arena.
I love it. That brings us to the final two questions from all of my guests. Number one is, what is your most important first principle?
So, look, that's a very, very interesting one. And my most important first principle really is come into being. It's all about the customer experience. So you put the customer experience first, and then you work back from that. It's not about technology. It's not about the API calls or the cloud service providers or which deep neural network or recombinant neural network that you're using. It's all about the customer experience. You've got to get that right, because today, given all of the capabilities that we have on these smartphones and at our disposal, we can vote with our feet very easily. If I don't like a particular service provider, it's very little effort to go and move to another service provider, and they're very easy to find as well. So it would really be around that whole concept of get the customer experience right. Once that's right, everything else will fall into place.
I so agree. The second question I have got for you is, what is one book that you have read and thought it would have been better for your younger self to have?
Actually, it's a very, very old book, and I wish I had read it right in the beginning, because it would have saved me a lot in my career, because I've worked in hardware companies and software companies and database companies over in America, and all the way to customer experience companies here in Australia. A book that changed my view of how to produce projects, how to actually get projects delivered correctly and easily and under budget, and be able to affect the world, was a book called The Mythical Man Month. And it was done by an IBM project manager who built OS 360. And he sat down, and back in those days when they were building the operating systems, they were building them through teams of 300, 400, 500 people sitting down, coding away for months on end. And IBM tried a different kind of process when they built the operating system 360 for their mainframes, is that they had two teams put two of them together to compete with each other to see which one would come up with the operating system first. So one did the traditional waterfall, very, very large group with lots and lots of programmers. And the Mythical Man Month goes, if it's going to take you 1,000 man days to produce this, and you put 10 men on it or 10 people on it, then it takes you 100 days. Or if you put 100 people on it, it takes you 10 days. Or if you put 1,000 people on it, you can do it in a day, right? So there's the mythical part of it. There's no way you can build a whole operating system in a day with 1,000 people. But the other team was a pared down team of very, very good programmers, but instead of it being a team of 500, it was a team of 10. So it was very focused. And they were able to produce the whole operating system before the bigger team. This guy did some analysis on it and figured out why it actually worked with fewer people meant you get things done quicker. And that's a really hard concept to handle if you think about it. And the reason why is all about communication. Hits right back into what we've just been talking about, right? The more lines of communication you get, the more complex of those communications, then the slower a project goes, the slower the interaction goes, the slower the transaction to actually do whatever it is that you're trying to get done goes. And you think about doing a mortgage application where if you have to deal with 5 people, just getting all the paperwork backwards and forwards to the real estate agent, the vendor, the bank, all the different people and manage all of that is very, very complex. And it makes a transaction as buying a house a very long process. But if you could reduce that down to a single line of communication, a much simpler form of communication, you get things done more accurately, faster, cheaper, and sooner to market. And that's what the Mythical Man Month book really showed me. So I wish I'd known that ages ago, because I've been falling into the trap of the many hands make light work, right? Now, if it's going to take me a month, I'll put a couple of people on it. It should only take a couple of weeks. It just doesn't work that way.
I love it. If that's okay with you, I just want to add a few of my thoughts into what you just said. I think the misconception that sometimes we have got about running a team and organizing the communication and trying to be as effective as possible, that misconception of the traditional way of how we are trying to do that is we are setting up rules and rules and rules about how to be communicating to each other so that we can communicate more effective. The problem with that is the team get larger or things get more complicated, it becomes harder. So no matter how we try to do that, it will never be effective. Perhaps the better way, in my own view, is that it's actually reduce the necessity of the communication and the organization and the dependence on each other. And I think to some extent, API is the beauty and is a great invention for the world, is that instead of trying to communicate, all we have to do is how can we minimize that whole communication to each other, but rather we spell it out in a way that this is exactly, you just have to fit the information for us. And one of the things that I have done to introduce that is, for example, rather than having to communicate with the programmer or the developer of like what are the changes that we need to make, is to design the system and the platform in a way that it can be completely driven by the data and the table. Because whenever I have to communicate with the developer, is that it will have to take weeks to implement, make them to understand. The developer have to understand exactly what I want them to do. And equally, when they are making those changes, there is risk in screwing up when commenting, uncommenting, adding the code. But rather, if I just have to change the data in the table and the program just pick up all of those changes, that changes just happen effectively and immediately.
Yeah. Yeah, absolutely. No, you're spot on there, right? It's how do we make communication even simpler? That is the thing. That's the key to getting more done. And but it requires data. You're going to have all that data in the background, or else you can't simplify the communication. So it's all very much tied together.
Thank you so much. And I have to say, Michael, That was a really, really great conversation, and also a great share of all the knowledge in so many different areas: biometrics, cybersecurity, AI, and some great story comes out about what is happening in all of those history that brought us all of these amazing technology that we are all using today. So I cannot thank you enough. And once again, thank you.
Oh, thank you, Jason. No, it's been a real pleasure and honor to speak to you. I really appreciate that, because on a bit of a crusade to get the idea out that it's about customer experience, it's about communication, and always love these conversations. Thank you.
Thank you.